times higher than global average. Some places in the Arctic even at 7 times higher than a global average. So we know that we're already facing the warming is so high in even the rest of the world. But if you look at the Arctic, if you go by an opportunity to go to Greenland and Svalbard, you can see that summertime you don't get any more snowfall, you get rainfall. The rainfall becomes so common in the Arctic region. So is Antarctic, especially the West Antarctica in the Antarctic Peninsula. So this kind of anomaly is something which is changing the weather patterns and the climate system. The Arctic amplification, which we call actually that whatever is actually compared to the global average, how much is being amplified in that area, which is due to many factors. The polar amplification is due to many factors. The most important factor is albedo feedback, because as ice start melting, you have this small, I originally mentioned ice is nothing but a white body, it reflects nearly 90% of your radiation back, whereas the ocean absorbs nearly 80% of the solar radiations. Any area become wet and start melting, start absorbing more heat. And as it's absorbing more, actually start melting more. It's a kind of a complete feedback chain. And of course, then there are other processes like this, the polar jet streams and how they take from the 1979 when satellite data started to which we consider actually as an average base in 2000. Every change, most of the dramatic changes are happening after 2000. That means in our recent time. We find at least nearly 50% of the Arctic sea ice is being lost in even that particular such a small period, about 20-25 years. Look at Antarctica. Mostly the West Antarctica is losing ice. Antarctic Peninsula, which is already a warm place because it's much closer to the mainland, which is in fact very close to the South America, is also been warm always. But what is the most important thing is actually what over here, the West Antarctic ice sheet is losing its mass to two major glaciers like Pine and Toy glaciers, and this could this has a big problem because it is like the glaciers and the ice shelves are like our belts. You got a loose span and if you have a belt which is strong enough, you will ensure that actually it will still remain intact to your body. But these ice shelves getting lost will be a dramatic change to the entire Antarctic ice because these ice sheets start behaving then as a viscous body. Now it's being it's becoming actually more like a solid, but it starts moving as the bottom of this with the land is very greasy because of the melting, as I mentioned before. Actually, the ice is melting at the bottom, and this can start to speed up the entire ice sheet to the ocean. What is happening in such a remote place are impacting us. The various ways actually the polar climate is impacting us on day-to-day life. Currently, it's changing the rain and snow patterns, which are already fine, there is a more rainfall, you have more latent heat rainfall, release and impacting this climate system. You have a change in, the increased heat waves reaching the tropical heat waves are also considered to be related to that. And so the mid-latitude and the polar heat waves. Cold waves, which is coming from the polar regions to the tropical areas, sometimes certain winters are getting colder and colder some places, and suddenly you can have this kind of cold waves coming in. There are increased droughts and loss of wildlife, the fires, which is increasing more and more, all due to this imbalance which is happening to which I will come back, is leading to extreme weather. Under normal circumstances, what we see typically a very strong jet stream around the Arctic Circle. It's so strong that actually it behave like a big boat. But in the case of as Arctic is warming faster than the rest of the world, this polar vortex start wobbling around, meandering to down south, as well as the air mass from the south goes to the north. So you have this warmer air reaching Arctic regions, as well as the colder air coming down to like you must have seen recently in the case of US and so on. So this is something which actually are actually happening now, which we can actually it's recovering, but still the impact is so much that it has led to so many changes in Antarctica and around the southern hemisphere. So we expect more and more atmospheric rivers touching Antarctica. This is a classic case where actually, once one of this reaching to Antarctica, which changed so much. In one day, the temperature at Domsey in Antarctica, which was supposed to be about minus 60 or minus 70 at that time, in one fine morning, it reached about 38 degrees Celsius increase in temperature in just one day. So that is the dramatic changes it can bring. And some of our studies clearly show that most of these atmospheric rivers come all the way from the subtropics and tropics, carrying so much of moisture with them. And what is more important is that such intense atmospheric rivers can ultimately impact the ice shelves. As I said, ice shelves are the supporting bodies, which I was just typically. This is what we call ice shelves, which are floating above the water. These are ice sheets on here inside. So whenever most of this, about 60% of most of the calving of ice shelves in Antarctica is found to be directly responsible from the atmospheric rivers. So under future warming scenarios, we expect that increased frequency of atmospheric river events could increase the loss of these ice shelves. So as I said again, the loss of such ice shelves can trigger a complete different mechanism than what we've seen in Antarctica as a normal loss of ice sheets as well as the dramatic flowing of ice through the ocean. So there is a clear picture actually emerging of late. There's a linkage between what happens in the polar regions to what happens in tropics. We consider normally actually they are remote from these two, such